In this video, we will use our tools for reasoning about exponential relationships to determine when the populations of two towns are equal when those populations change exponentially. So consider the following example. Since 2000, two different towns had populations that changed exponentially. Town A's population was 42,680 at the beginning of 2000 and changed by 2.8% per year. And then Town B's population was 57,920 at the beginning of 2000 and changed by negative 3.7% per year. And we want to know how many years since the beginning of 2000 did the two towns have the same population. So first of all, we're thinking about a number of years since the beginning of 2000. So let's define a variable to represent that. So let's let the variable t will represent the number of years since the beginning of 2000. So we'll just write number of years since 2000. So let's start by considering Town A. So Town A had an initial population of 42,680, and it changed by 2.8% per year. So for Town A, we have a 1 year percent change of 2.8. And a 1 year percent change of 2.8 corresponds to a one year growth factor of 1.028. So this 1.028 comes from the fact that at any given year, the new population is 102.8% of the population the prior year. So this 2.8% change corresponds to a growth factor of 1.028. And we had an initial population of 42,680, and therefore we get to define a function a. So we'll define a function a to represent the population of this town. So a of t, which represents the population, starts at 42,680. So 42,680, and it has a 1 year growth factor of 1.028. So our function formula is a of t equals 42,680 times 1.028 raised to a power of t. Now let's handle Town B. So for Town B, Town B has an initial population of 57,920 and changes by negative 3.7% per year. So a 1 year percent change of negative 3.7 corresponds to a 1 year growth factor of 0.963. And this comes from the fact that each year that passes, we lose 3.7%, and so we're only keeping 96.3% of the population, and 96.3% of the population is 0.963 times as large as that population. So then we'll let a function b represent the population of this town. So b of t represents the population of Town B. It starts with this 57,920. So let's write that down. 57,920. And we have a 1 year growth factor of 0.963. And then we'll raise that to a power of t because we have an exponential function here. So now we've got two functions modeling the population of each town in terms of the number of years since the beginning of 2000. So what we're trying to find out is where is a of t, the population of Town A, equal to b of t, the population of Town B. And to solve that, we can plot both of these functions and then find where they intersect and look at that value of t. So let's plot those two functions real quick and see what you get. The plot that you get should look something like this. We have the graph of A. It's increasing because we have a growth factor of greater than 1. And we have the graph of B, which is decreasing because Town B's population is decreasing. And these two function graphs intersect at this point here, 4.67, 48,561. And this 4.67 is a value of t, and that's the value of t when the outputs of those two functions are equal. And therefore, that value of t, so let's highlight that, 4.67, is the solution to this equation up here that we were trying to solve. And therefore, t equals 4.67, or approximately 4.67, is the solution to this equation, A of t equals B of t, which tells us how many years since the beginning of 2000 when the two towns have the same population.